इससे अच्छा कोई मूवी देख लें 2 घंटे की। इसे देख के तो सीखेंगे नहीं कुछ भी।
जी सर।
चलें फिर देखते हैं, कोई रैंडम सा क्वेश्चन उठाते हैं, उसको सॉल्व करते हैं। दोबारा प्रेजेंट करने का तो फिल वक्त मुझे कुछ, it's okay to get stuck in a new problem than to repeat something that we are comfortable with, uh, unless we
जी
are
सर, स्टार्ट स्टार्ट कर दीजिए, लाइव हो गया।
okay. All right, let's see how far we go with the new question. uh, Ransom node, this looks very attractive. Let's see. Bismillah. All right, so ransom node 383 given two strings, ransom node and magazine. Return true if ransom node can be constructed by using the letters from the magazine and false otherwise. Each letter in the magazine can only be used once in ransom node. It appears that we are given two strings. One is a ransom node and one is a magazine. These two are strings and not exactly a magazine. But what they're asking is return true if the ransom node, this string right here, can be constructed by using the letters from the string magazine. This is the string variable. If this can be constructed doing that, well, we can return true. And if it does not, then we need to return false. Each letter in magazine can only be used once in ransom node. Okay, so um, so the magazine is what carries the letters or the number of letters, and you're allowed to use each letter of the magazine only once to try to construct this ransom node. Okay. Now, in this case, you have a B in the magazine, and you cannot construct A with B in any case, right? Then we have second example where we have A and B. Can we construct this entire string using all the letters in the magazine? No, we can construct A, the first A, but the second A cannot be constructed. So it seems like we are somehow, uh, well, it turned into an emoji. So we are somehow trying to construct this. So I'm thinking about like if someone tells me go build a building, construct a building, okay, and this project is assigned to me. So for me, the work would look like, okay, I have constructed until this, okay, so now I can focus on the rest of this, which means during construction, you can build this portion once and then you need to keep going forward. It sounds like simple iteration, but the intuition behind that seems to be um, you're constructing it. So if you have built this, it doesn't mean you'll be able to build this area. If you have been able to build this area, it doesn't mean you can build the middle one or even the rest of it. Okay. So if we shouldn't get too, I think we should not get too optimistic by having the similar letters. The frequency matters. If I'm able to keep up the pace, I should be able to build the building, construct the building. Otherwise, I won't be able to. So yeah, I was able to build. I saw that there's one A, and I'm able to build this A. Okay. And let's see if they're saying if the order matters. The order definitely matters. If I've noticed on LeetCode, if the order does not matter, then they do mention it, but here they haven't mentioned it. So we have to construct the exact same string by using letters from this. And if you're able to, then we're at luck. Okay. Okay, right here we have A and A. So are we able to build this A and A from using letters from this string? Yes, using A and A. Okay. Regardless of how many more letters we have in the magazine. Now the question is, do we need to follow the sequence, or we can take if we have something like A, B, A, and as long as we're able to get two A's and two A's, we should be able to build a string. So I think the scope of the question is we should be able to build a string from the material we have been provided. Okay, I think that's what we're going to do for this question. But let's look at the constraints and maybe look at some more clarity. So ransom node.length, magazine.length, what it's telling you is the length of the ransom node and the magazine string. They are between and including 1 to 100,000. Okay? And 100,000 would be something like this. This can be the total number of string characters inside the magazine string, and it can also be just one. Ransom node and magazine consist of lowercase English letters. So you won't have any uppercase letters. You don't need to do any equal ignore case for the uh, upper or lowercase. So it doesn't have to be case sensitive, your solution, I mean. Um, Topics you can look at it, hash table, string, and counting. So this is just a huge giveaway how we're going to solve this. As long as the frequency of the as long as I'm able to find the number of letters that we have here in here, then we have the answer. For example, if I map these two A's inside a hash map and set count to 2, next time when I iterate over the magazine, I'm going to go over each letter, and whenever I'm able to find A, I can keep subtracting 1 each time. As long as my hash map has, and whenever, of course, whenever any of these letters reach to 0, what I can do is completely eliminate. Well, I don't need to eliminate the hash map. It will be just an empty hash map, right? So that's what we'll need to check. If the size of the hash map by the end of our code becomes 0, can I assume that I was able to find all the letters in the ransom node from the magazine? Therefore, I am able to build using letters once. I'm able to use, I have all the letters in the magazine that I can use to build the ransom node. Okay, that's a pretty easy question. Let's dive into coding this solution. Seems pretty simple to me, but we'll find out if it's otherwise. So let's initialize a hash map with the type, I would say string. The key should be string, and the value should be an integer, which will be our count, right? And then I'm going to name it map equal to hash map, and let's close it up. And now I'm going to loop over for integer I equal to 0, starting with the 0 of this string right here, okay? Starting with 0, going, taking my I all the way to the end of this string. So I can say ransom node dot length. And I can do, since this is a string, so I'll have to put 2 round brackets. Basically, this is the function from the string. If it's an array, I don't need to do that. Okay, that's how it is in Java. And I can do I++. This will take me all the way to the end of this string, the ransom node. So right now we're trying to map the ransom node, put it into a hash map it to its count. So since I mentioned count, we do need an integer count. We initialize it to 0, no worries. And okay, what you can do here is you can do map dot put in order to map the I can do ransom node, which is basically string dot character at which index ith index, and map that to um, count being, map that to count being. I guess we can just do this. We don't even need this. Okay. Initially, the count for each character will be one. So we'll initialize it with one. Okay. So this we will only do if that character does not already exist inside the map. So can we say um, if the character at if the character at I of the string uh, is not contained, map.contains, and we can do, if map does not contain, we can just do this. If map does not contain, this basically makes it false, okay? If that does not contain character at I, in that case, we can initialize it with count one, okay? But if it does exist, come on, format my code. Me too. But let's say it does not exist, we can, in that case, simply what we can do. Sorry, if that, this means it does not contains, okay? Does not contain. And if it contains it, then simply what I need to do is map.get character at I, okay? And once I get that, there's one more thing. Let me look this up. I don't know how to increment value. Once I'm getting this, no, this will be map.put, map.put, character die. Let's see, I need to pull this up. How to update value of a key in a hash map, in Java. Okay. So yes, we're going to use the put method, but I need to see if it's a count. Let me show you what I'm looking at. So let's see. Implementing value enhancement Java by one. Let's see, let's look at this. We can do this method right here. Yes, this will work. Okay. So we can do character at I, and that word.count, basically the map itself, get or default. This will be again the character at I, and with zero, the zeroth index, I believe. I think that's what it means. And then we can increment it by one. So this will suffice for our purpose, okay? So I'll just copy that from here, just for the sake of ease, and now we'll make our changes. This is, so first let's replace the name of the map, okay? Then this is the character at I. So I'm going to take this here and replace it with the character at I, because this is our key. This is going to keep changing, and then we're going to increment it by one, okay? So once we have all the counts, okay, next thing what we need to do is we need to iterate over this magazine string, right? So I'm just simply going to copy this loop and I'm going to put my changes inside. And every time I come across any letter that is already in the map of the ransom node, I think I can just name it ransom map. Okay, it's gonna be easier to understand it. But ransom map, okay, whatever. Who cares? Ransom map, and let's change the if ransom map, ransom map, ransom map, ransom map. Okay, so for integer of, let's make it j to remove the confusion. Otherwise, I think it's, since it's out of the scope and it's in the local scope of this, so You can even use I. And the next string I need to take is the magazine, okay? So for the length of the magazine, I'm going to iterate all the way to the end of the string, and I'm going to keep getting the letters and keep checking them in the map that we have created, okay? Which is the ransom map. If it exists, the map, we're going to decrement the count, just like we did here, okay? And we will also check if the ransom map, if that this value right here becomes zero, a count becomes zero for some key, then in that case we can just remove that uh, entry altogether. Okay, so first check we need to make is if, similar to this one. Okay, if if ransom.map if ransom.map contains character at j. Okay, now what we want to do is we just want to find the letters to remove. Okay, if that contains the character at j. Okay, um, and character at j. Okay, in that case, what you do is you decrement by one. So if I take this, yeah, if I take this is the right one, and I decrement one, okay, and then I check the count. If uh, ransom map ransom map dot get ransom map dot get value of character at I, character at I, okay, character at I. If that has been reduced to zero, then in that case, I can remove that from the map altogether. So ransom map dot key, remove key, okay, remove key, and I can just give that key right here. Remove that key, that's gone. Now, once this is removed because it arrived at zero, then when it arrives back at this condition, it will not contain that. So it will move on to the next letters, okay? So if I'm able to uh, completely deplete the ransom map of the resources, then can I say I have found all the letters that are needed to build the ransom node? Because I build the ransom node, I'm deleting from the ransom node, and I've explored the entire magazine, okay? So finally, what we do is we check if the ransom map, if the ransom map dot size equal to 0, then return true, else, or we can just do return false. Okay, so what did we do here? Initialize the hash map. Excuse me, reduce these lines. And then we started iterating over the ransom node to build a ransom map. And if the ransom map already contained something, then in that case, it did not contain something because of this exclamation mark. Contains becomes not contains, right? Then we would do is we would add that entry, that character I, and map it to count one. If it already contains that, so in this case, this becomes opposite, right? If and else, then we would increment the count for that particular. So for example, if I already have an A inside that hash map and I arrive at another A, then if the value of A is 1, I do +1 and now I have found two A's, right? In the next step, we run loop over the magazine and the intention is to find the letters that will be used to construct the ransom node. And the idea is if we already had a build ransom node, what would we need to do to completely deplete of it? We need to minus exactly the same material that it's been used to build up, that's been used to build this up, right? So the idea is to subtract the letters from the count, okay? And that's what we do here. We run over the magazine. If we find the character, we subtract by 1, and once A is being mapped to 0, we check this value. If it's 0, then we just remove this entry completely, okay, from the ransom map, because ransom map only has the letters that it needs. So if I'm able to find all the letters in the ransom map by subtracting, it will lead us to uh, the size the size of the map to 0, which means it will be an empty map. And in that case, we can return true, else we will return false. Now, I think there are going to be some syntactical issues, errors that will cause us to fail because some of these things I'm not sure about. But let's give it a go. If not, we can correct the syntax by using GPT. No worries. So I'm going to, where's my panel? Right here. Okay, let's run this code and see. Yeah, I told you. Hash map, I think that's going to be a new hash map, right? Yeah. Then they're saying, okay, there's another issue. Saying the ransom map contains character at I. Okay, what's the problem here? Character at I, and then there's this opening bracket. Okay. What's expected? No, I think mm, it's going to be like this, equal to 0. Hmm. I guess I'll need to change this. Let me give it a go. What if this works? No, I'm gonna feed it to GPT. I'm not gonna waste time on this. Correct syntax. Okay. All right. So, well, it has fixed the syntax exact same code with the only difference is that if the map is empty, if it's actually empty, it'll return true. If it's not empty, that will return false. So it has just optimized the code with respect to the syntax. So I think this should work. Let's run this. And at least 3 cases have been accepted. Once we submit it, I hope to see it work. Yep. We can analyze the complexity. It's going to be bad. Of m plus n. M is the length of string first and length of string second. And of course, base complexity is going to be okay. 44.61 megabytes memory beats 83.32. Not as good of a solution. Probably will have an optimization for this as well. But anyways, so this was your basic question. We have seen this pattern. We've used this pattern in arrays questions. And this was very helpful to keep the count of frequencies using hash map. You can use hash map a lot. Yesterday, I connected with Hadi, and he was showing me a dynamic programming problem. That is the climbing stairs. And he was showing how um, he was able to resolve the issue with timeout because the recursion was recomputing the recursive calls over and over again. So he ended up using a hash map And whichever recursive calls he was able to solve, he was just mapping them to the hash map. So next time the recursive calls would not recalculate all those. So anyways, that's a question for later. So we can mark this question as done as well. Okay. Uh, I'm updating the sheet again presented by me. So whatever. Okay. Um, all right, let's look at this question. Reverse words in a string. Oops, it's a medium question. Okay, anyways, let's see. Given an input string S, reverse the order of the words. A word is defined as a sequence of non-space characters. Okay. So we need to reverse the words in a string. So first we need to understand what words are. If you're seeing these letters, these characters, these are non-space characters, which means there's no space between them. In fact, the space is between the and sky, right? But if you see here, after E itself in string itself is a character at an index. So there's a space character. Space itself is a character. Space character between E and S, and then you don't have any space. So this is a rule that makes this a word and this a word. It makes this a word and this a word as well. Okay. So that's the idea behind words, that you can separate them with using what? Spaces. All right then. A word is defined as a sequence of non-space characters. The words in this will be separated by at least one space. At least there'll be one space. There can be two, three, four, whatever number that you may think of. And return is string of the words in reverse order concatenated by a single space. You need to return a string of words in a reverse order concatenated by a single space. So, well, oops, what does that mean? We'll see. That S that S may contain leading or trailing spaces or multiple spaces between two words. The return string should only have a single space separating the words. Do not include any extra spaces. Leading spaces would be something that starts here. Okay. Like for example, there's a space and then these started. And trailing spaces or multiple spaces between two words could be like this is one space, and if I had set two space, that would be it. Leading, trailing. I don't know what trailing spaces means. The return string should only have a single space separating words. Okay, so you need to also delete the spaces, which means that in between the words, there should be only one space. That means if this string right here had something like this, two spaces, okay, and then sky. Now, when you return the reverse string, it should look something like this, sky with a single space and the. So in this case, blue is sky, the, with single spaces, no trailing spaces. So you'll need to trim those spaces on the sides, and you need to keep a count of spaces. Wherever you find a count of space exceeding one, size one, right? That's where you need to delete that space and reduce it to one, and then add it back where it belonged. At least that's what I'm thinking. That's how it should be solved. Okay. All right. Then let's move to the next example. Hello world, it has leading space. I think this is called trailing space. This needs to be cut out. And if there's space between these two words as space that is more than one, then you need to remove that. If there's no space, that means that's a single word. Okay, your reverse string should not contain leading or trailing spaces. Makes sense. S equals a good example. Okay, here you have one space and two spaces, so you need to reduce that. Example, good A. You need to reduce multiple spaces between two words to a single spin reverse string. The length of the string is 1 to 10 raised to the power 4, S contains English letters, uppercase and lowercase, digits, and spaces. There's at least one word in S. If the string data type is mutable in your language, it is not mutable in Java. Can you solve it in place with one extra space? Okay, that's just space optimization. Okay, let's look at the approach that we can take. If I'm given a string and I have the trailing spaces and extra middle space, okay, 2 spaces, and I also have trailing space. This is trailing space, this is beginning. So right off the bat, if at my 0th index, I have a space character, I need to do something to just cut it out. And I can do like a pre-check on the both end of the strings. What is the last index of the string? Last index. If it is a space character, we need to reduce it. We need to cut it out, okay? So in other words, I think we'll need to rebuild a string where we are iterating in the opposite direction. We're taking each word, okay? And if we have a space here, we remove it. If we have 100 spaces here, we need to make sure we remove them, right? Until we get it a word, and then our space count starts, okay? Now, what I'm thinking is, if I start on the opposite end of the string, I should not start counting my words until as long as I don't have a space here, which means that if I'm starting here and I have a space here, okay, I do not start counting my word. Once I've gotten rid of the space, my iterations should, or my count should start here. Now, this is the first word, and the middle space will start from the first word, right? And the reverse string. So after this, I will count what is the space. If there's a space, is the count of the space 1? If it is, then good. Then I can move to the next word and next word. So what if between sky and is I have multiple spaces? I start counting the space. Okay. I start counting the space and or I have another idea. I don't even count space. I count words, okay? And I ignore spaces. And when I'm adding that to new string, after I've ended with the first word, I encounter the next word, I add it with 1 space. Okay, this way I can make sure I'm ignoring the spaces on the right side and on the left side. So the idea should be we completely ignore the strings until we find a word, and then we start counting the spaces. We will start checking for the spaces. Even if it's 1 space, we don't consider it. Actually, we consider it. If it's 1 space, we consider it, and we find another word. If I haven't found word in the next window, now I have a problem, right? Then in that case, I just keep looking. I keep looking. I keep looking, and then when I find a word that is a non-space character, then in that case, what I do is I add that word with just 1 space. So let's see how we can go about it. This is the first time I'm solving this, so probably second. I don't know. We'll find out. String. This is a 1 space that I would like to add to my answer string. So string answer string equal to empty string. Okay. This will be just 1 space. Okay. This is just 1 space. And then I have my string s, which I'm going to iterate over in an opposite direction for so I need to start with for integer I is equal to s dot length -1, which means I'm starting from the last index, okay? S dot length -1. And I is, well, I is greater than or equal to 0. I can do I minus minus, and which is decrementing it by 1. And if What if you can use a while loop instead of for loop? Because for loop will, okay, we'll see. Okay, it doesn't matter as long as we have the operations right. So I'll keep decrementing on the opposite side if the if s dot character at I is equal to an empty space, okay? Because I'm starting from the end of the array. What I do is I need to have an integer for space count. Here, space count is equal to 0, okay? So if there is a space at the, no, we decided something. What we decided is that we're going to ignore we should do a pre-check. So if I do a pre-check here, whether whether I have space right here, then when do I start my iterations? If I'm starting here, there's a space. There can be hundreds of spaces. Mm, that would end up being pre-optimization. I can run a loop if the last letter is not it's not just about the last index anymore. Yeah, so we cannot do a pre-check. What if we have 100 spaces? So then we'll need to check 100 indices just to make sure we are trimming the right kind of space in the beginning and end. So I think what we can do is we can just include, as long as we're finding spaces, we just keep ignoring it for now. Okay, if this is this, can do one more thing is the integer length, uh, do a space length is equal to one space, one space dot length. I know this is overkill, but that's how I'm thinking right now. Okay, now if that is this, okay, if this is an empty string and that character, okay, I ignore it, I continue. I continue, okay? I ignored that. And I ignored this, else else what to do? Else if it's not an empty string, then in that case, now how do you count the words? We can iterate over this. We can keep going. And then we need to check for the space again. So if string character is this, string of character of I is this. Is one space. If it is one space, nope. This. If it is equal to the one space, and since this is equals, this is string, one space. And in that case, what we can do is we can do initial length is 1. Okay, so we should set it to 0. Okay, and in that case, space length plus equal to 1. Okay, and the space length is equal to 1 is, can I say less than 2? So if my space length is not exceeding the count 1, in that case, even though there's one space, I ignore it, right? So in what cases do I ignore it? One is before, one is after, and one is in the middle. So if I am ignoring the first space, what if I have multiple spaces? That's why I was thinking I should use while loop. So while I keep hitting space and the length of the space is equal to 1, and the count of the word is 0, okay? So I think I need to go based upon the count of the word. If the count of the word is equal to 0, that we haven't counted any word yet, and I have a space, I simply continue. But once I hit a non-space, I can start counting a word until I reach another space. So now my count becomes 1. Okay? Now if the count is 1, I do not need to ignore. In fact, I need to count spaces. Okay? And then when I hit a non-space character, I can jump into the second count and third count. And if I reach the end of the string, then I have found words. So after the count is 1, I need to add my existing word to the uh, new string, which is the answer. I think I'll need to redo this. I'll need to redo this. Okay, so I'll remove this. If I do while and I need to have a word count. Okay, integer word. No, word equal to 0. And iterator. Okay. While iterator is iterator should start from the end of the string, right? So this should be s dot length minus 1. It'll start from the last index, and iterator is greater than or equal to 0. Okay, we keep doing this. And
सर थोड़ा जूम इन कर लें कोड जो आप लिख रहे हैं ना वो बहुत जूम आउट है ठीक है
while iterator is greater than or equal to 0, and we're checking the word count, we're checking the space count. Okay, and then we have answer. Okay. While iterator is greater than 0, and the word count and the word count is not equal to 1, let's give it a freedom. Let this while loop go all the way to the end of string. If the word count is not equal to 1, and if the word count is not equal to 1, and the s dot character at iterator, okay, character at iterator, if that is equal to, if that is dot equals what? One space, okay. If that is equal to one space and we haven't counted any words, in that case, we can simply ignore that because we're trying to trim it, right? So in that case, we can trim it by just continuing by adding or subtracting -1 from the iterator because we're going in the opposite direction. And then we can just simply continue, which it will, of course. But just for clarity, I'm just typing it here. We can remove this. We continue, and the next condition we check is if word count is not equal to 1. And word count can still not be equal to 1. But in the second case, we need to make sure it's not one space. Okay. We don't need to count spaces if it's on the end of the string. We need to just count spaces in between. At least I think that's how it should be. If word count is not equal to 1, and again we find another one space, the character is equal to one space. In that case, what we do? In that case, if the new character that we have found is not equal to one space, right? In that case, what we do? In that case, we start counting the word, right? So for that, we can build our answer, okay? So answer plus equal to the character at the iterator. We can add that here. So now we start adding the letters, okay? Okay, but the problem is if I'm adding letters, just the letters, it will add in the opposite direction. EULB. Yeah, it will come here. And then we can do string dot reverse. We do string dot reverse, and then we add that to the new string. Okay, so let me add this to the yeah, we can do answer dot reverse, string dot reverse, and put answer in it. So I'm going to keep adding this, and the count of words still will not be equal to this, and it will still not be an empty space. In that case, we can keep adding characters. And in any case, if we need a third condition, and we can later, put it all together and remove unnecessary conditions. If the word count is not equal to 1, and now we have Hmm. So when do we increment this word count? When do we increment the word count? We increment the word count. I'm building the answer. Now I have again, once again, hit the one space and my count is not equal to one. So I think we should increment this word count as soon as we hit the character, right? Because from there onwards, you'll have at least, a letter that will start a word. So in that case, what we can do is, if word count is not equal to one, we can uh, word count plus equal to one. In that case, since word count is plus equal to one, which is one, um, now it can come to this. If word count is equal to one and we don't have space, we can just keep adding this. Okay, we can keep adding this, and we don't need to add this. Okay, we only add this uh, when you don't have a space anymore and word count is not equal to one. Something needs to change here as well. So we'll keep adding this. And once again, when we hit our space, but in that case, word count is not equal to one. Uh, so next thing we need to check when the word count does not remain zero. Can we do if word count is greater than zero, or we can say less than or equal to zero. In that case, run this. If word count is less than or equal to zero, and it's not a space character, okay, less than or equal to zero. In that case, increment your word count and start adding the answer, and then move on. Then the next condition, it will come here and say if the word count is greater than zero and it's not a space character, you can keep adding. And the fourth condition you can do if it's equal to space again. It's greater than zero and it's equal to space. Then in that case, you need to apply the same conditions. You can keep moving. Okay? You can keep moving. Plus you can add this. And now you need to handle the case here. And also you need to reverse this string. Okay? So you can do. The meeting's gonna end in a second, but I think you guys have now an idea of how to do this. Answer. The string is reversed, but you need to find a way to reverse this properly so not everything gets reversed back into the same string. Okay, you can continue. So this is all from my side today. Thank you all for joining. We can solve this question on our end and present it on Monday. But yeah, I'm looking forward to linkless questions more and more. I hope you guys like the session. Thank you.
ओके, थैंक यू सो मच फॉर पार्टिसिपेट्स एंड मॉडरेटर, एंड थैंक यू सो मच मोहम्मद तरह, आपने अच्छा से क्लियर समझाया। तो
Thank you.
किसी का कोई क्वेश्चन है तो काइंडली पूछ लें, अदरवाइज पे हम सेक्शन को एंड करते हैं। ओके, तो फिर हम सेक्शन को एंड करते हैं। थैंक यू सो मच फॉर पार्टिसिपेट्स एंड मॉडरेटर, थैंक यू सो मच मोहम्मद तरह।
Thank
तो
you.
अल्लाह
Thank
हाफिज़।
you.